Hello fellow problem solvers, so today I'll be doing a problem from the 2022 JBMO problem number 3. This is the JBMO where I was one of the coordinators on problem number 4, but this problem number 3, is a nice technical number theory problem that I suggest you try out for a minimum of 20-ish minutes, ideally 45 to maybe an hour and a half, not more than 4 hours if you'd like to go along with us. But your first time, read the problem. Okay, so read the problem and then put your first ideas out on paper for the next 5 minutes. And now let us begin. So, all quadruplets, okay, PQAB, that's a lot of numbers. Okay, P and Q are primes. A is bigger than 1 such that this is true. Okay, so what is maybe the first thing you see here? Well, it can be a couple of things. So for me, one of the things I see is, oh my God, if only A was even, then I could take the one here, write this as a difference of squares. Like this could be P to the power of A over 2 minus 1 times P to the power of A over 2 plus 1 is equal to 5 times Q to the B. And then I could figure something out about what P and Q are. From there I can maybe solve that case quite easily. And here's an important part to note. Sometimes in problems, you can assume a certain thing. You can say, assume this is true, and then solve the problem. And that can actually give you points. And here for this problem, if you just solve the case for A is even, without ever justifying why A has to be even, or if it even has to be even, you would get 3 points, right? If you did nothing else but just solve the case for equals even, that's 3 points. And for this actual competition, I think the cutoff for silver was around 21-ish. So those, if you have 10 and 10 on the first two, just assuming that and solving it gives you a silver medal. So it's important to know these things. Sometimes, hey, you can just assume these things and you could. But now let's, that can be a thing you want to solve. Pause for 5 minutes, try to solve it, or maybe 10, 15. But the thing I want to focus on here is, okay, what is sort of the big picture? It's hey, even if. So maybe if A was, we can even just go over that case. So if A is equal to 2 times some C, then I can write this as P to the power of C minus 1 times P to the power of C plus 1 is 5 times Q to the B. And now, Q could be 5, but if both of these numbers, their GCD is this minus this, which is 2. So if their GCD is 2, they can share at most 2. But then what do you see from there? Pause for 5 minutes. Well, if P was odd, then Q is 2. So it's either that, and if P was 2, then I would have these two share nothing in common. So these, one is 5, the other one is Q to the B, and then it's casework from there. Then this one has to be 5, and then, or actually neither of them work out. Actually, wait, they do. 4, what's it called? 4 plus 1 is 5, that works, and then 4 minus 1 is 3, that works as well. So, but what do you notice with this? This thing that I've just done. I've looked at what? Pause for 5 minutes, think about it. Well, I've looked at a case P is even, Q is, P is Q is 2. And here, what do we have? Well, we have that if both P and Q were odd, we'd have an odd number is equal to an odd plus an odd times odd, which is false. Odd plus an odd is even. So it's either P is 2 or Q is 2. You see these things, you write them down. Worth 1 point. I have the marking scheme. So it's worth 1 point. You want to write these things down. 1 point, the difference between a silver and a bronze. That's why. These are things that are good to know. Now, we could go ahead and try to, okay, let's look at the case P is 2 and Q is 2, see which one is easier for us, and take it from there. So I don't know, let's go with P is equal to 2 first. And you want to try, also an important thing, something that I have a good experience with, because I've not done that, is sometimes when you have two cases, that we need to check. One is perhaps easier than the other. And you don't quite know at the beginning which case that is, right? You don't know which one's easier. So it's useful to try both out. Like if you're stuck with one case, move to the other one. I've done this and it's cost me, and it's like one of my IMOs, there are two cases, and I did just one case because I thought, no, it has to be easier. But the other case, which I did not attempt enough, was worth 2 points. I didn't attempt it, and it was it's not a stupid 2 points. It's still an IMO problem. It's not a simple thing. But I didn't attempt it enough because I thought, no, this one must be easier. And this case was 4. This one was 2 points. So try these things out, right? That's the big lesson I want to say here. So let's try with p is equal to 2 and see how we're getting. So this is the first case, like either p or q is 2. So if p was equal to 2, we'd have 2 to the power of a is equal to 1 plus 5 q to the power of b. Now, 2 to the power of a, we know it's congruent to 1 modulo 5. Modulo 5, what is 2? We have 2 is congruent to 2. 4 is congruent to minus 1. Okay, then 8 is congruent to, what is 8 congruent to? 8 is congruent to minus 2. And then 16, or 2 to the power of 4 is congruent to 1, and then it repeats. So if 2 to the a is going to be congruent to 1 modulo 5, that means that a is equal to 4 times some c, some constant c. So now, I invite you to try to push the problem further for the next 10 minutes. And here's the next step after we clear this thing up. And what we're left with is, when we plug that in, we're going to have, and move 1 to the other side, we're going to have 4 to the power of c minus 1 times 4 to the power of c plus 1 is 5 times q to the power of b. And I can even write this as 2 to the power of c minus 1 times 2 to the power of c plus 1. Okay, we're good. Now, what are we going to do next? What is q? Is not like we know what p is. Can we figure out what q is? We know one of these needs to be divisible, like one of these has to be divisible by 5. And my money's on this one. Actually, it's 4 to the c plus 1, 4 to the c minus 1. Yeah, like there's nothing to do with divisibility of 5. We have that covered now. So anyway, yeah, we've already used up modulo 5. That's important also to keep track of. Have I used everything with modulo 5? And when I said a is equal to 4c, I've used up modulo 5. There's nothing more modulo 5. Maybe modulo 25, there can be something else. But modulo 5, we're done. There's nothing else to be said here. Now, let's move on to what can q be? Well, maybe, one thing to do would be just guess a solution. Like see what some small cases give me, say c is equal to 1. They'll give me 5 times 1 times 3. Okay, 3 times 5, that works out. What about c equals 2? That gives me, that gives me 17 here. That's a big number. I mean, not huge, but in terms of this, why am I doing this? Why would I say it's big or small? So let's see, c is equals 2. Here it gives me 4 minus 1 is 3, 5. This gives me 3 and 17 both. In both cases, okay, I got a 3 and a 5. A 5 I know I'm getting a 5, but I got a 3 in both cases. I mean, maybe will I always get a 3? Pause for 5 minutes, figure this out. And the answer is, well, yeah. Like 2 to the power of c plus 1 to the power of c minus 1. I mean, one of them has to be divisible by 3. If c, there's a couple of ways to go about this. One is to just look at 2 is congruent, 2 to the 2k plus 1 is congruent to 2k plus 1 is congruent to 2 modulo 3, and 2 to the 2k is congruent to 1 modulo 3. So either one of the two will be divisible by 3. Another way to look at it is 2 to the c minus 1, 2 to the c, and 2 to the c plus 1 are 3 consecutive numbers. In other words, one of them is divisible by 3. This one sure ain't. So it's either this one or this one. And that's how we know this side is divisible by 3. So this side has to be divisible by 3, which means what? Q is equal to 3. Bravo. So Q is now equal to 3. And what are we left with? And we're left with this thing right here. And now we can go ahead and look at, okay, which one has okay, wait a second. One of them is going to have a 5, and the thing that has a 5 is, either this or this. But two of them are going to have a 3. And now one question is, can both of these two have 3s in them? Well, if both of these were divisible by 3, then their difference is 2. Ergo, not good. We have a contradiction. Can both of these be divisible by 3? Now that one's a tricky one, right? You're not sure, so let's check it out. Can 3 divide 2 to the power of c plus 1, and can 3 divide simultaneously both of these? Well, this number is, divisible, divides 2 to the c times 2 to the c plus 2 to the c, right? When I multiply everything by 2 to the c, it's still divisible by this, which is 4 to the c plus 1, actually plus 2 to the c. Subtract these two and I get 3 divides 2 to the c minus 1. Oh no, looky, what do we have here? A contradiction. Boom. Now, if this was a minus over here, we had a minus, we'd have a minus here, we'd have a minus here, and so we'd have a plus here, right, when we subtracted. So, in other words, 3 cannot divide 2 of these brackets, and 5 is only in one of them. So what does this mean? One of them has all the 3s, the other one has all the 5s, and the third one has all the 1s. So which one of these has all the 1s? Well, it has to be the smallest one. So 2 to the c minus 1 is equal to a 1. And so now we have 2 to the c minus 1 is equal to 1. And now 2 to the c is equal to 2, c is equal to 1. And from here we get that this is going to be 3 times 1 times 4 plus 1 times 5. In other words, b is equal to 1. And then a is equal to 4 times c. In other words, it's equal to 4. And what is our solution? Well, our solution in PQAB, PQAB is going to be PQAB. So P was equal to 2, Q was equal to 3, and then A was equal to 4. And here we had B was equal to 1. 2, 4, 3, 1. Now let's double check it to make sure we haven't made a mistake in any calculations. 16 is 1 plus 15. We're good. Nice. So, and this is the case. P is equal to 2. It looks okay. We want to double check everything. And now I want to have you pause for the next 10, 15 minutes. Try to look at the other case when Q is equal to 2. And before you do, I just want to say that this part right here was, I believe, about 3 or 4 points. Again, you want that silver? Go ahead and get it and write down. If you haven't solved the problem, write down this partial stuff. It may be useful. And in this case, yes, it is. So we had P equals 2, and it seems like everything is just fine and dandy. So let us continue on to the next case. And now we're back to the case Q is equal to 2. So for that other case, we had that when P was 2, we got everything we needed. But now we're going to have a different sort of equation with Q is equal to 2. We're going to get that P to the A, okay, minus 1. Now going to put everything on this side, is 5 times 2 to the power of B. Okay, interesting. Well, what if I'm looking at this now modulo, I can't look at this modulo 5 anymore. I just don't have that information here. So what am I going to do now? It's okay, I don't have modulo 5 anymore. What is B looking like? What is A like? Well, maybe I can, I know if A is even, I'm pretty darn good. So, I mean, I could solve it. So let's maybe, split it up. And again, I don't know what to do here. Like, what am I doing? How am I going to deal with a case if A is odd? I have nowhere to take this. I mean, I have P minus 1 times 1 plus B squared plus so on and so forth. But what am I going to do with that? I just don't see it, right? So, who knows? But I know if my dear lovely A that is even, I can write this as a difference of squares and then, maybe factor something out. So let me try that case and then leave that later. Again, this might be partial points. And in fact, this is between, actually, let me check it out. And the marking scheme isn't very clear, but you can get, I believe, a point or two finishing the case when A is even. So let us look at this case. A is equal to 2 times C case. This is case 2. This is case 2, subcase 1. Okay, so let's look. A is equal to 2 times C. We'd get P to the power of C minus 1 times P to the power of C plus 1 is 5 times 2 to the power of B. Now, what do we have here? Well, if this P was a prime, okay, so this is, they can, like, one side is even, the other one has all the 2's, but the other thing has only a 2 and a 5 at most. So we could have, P is not equal to 2, so this can't be 1 and something. This could be, one could be 5, one could be 2 to, like we have one is 5, the other one is 2 to the B. We could have the opposite happen, right, for some prime. Like this does not end up working. Both give me that P needs to, okay, P is even in both cases. So I think the only thing that ends up working is this is 2 times 5, and when this is 2 times 5. So in this case, I have P to the C minus 1 is equal to 10. So I have P to the C minus 1 is 10, and P to the C plus 1 is 12. Well, that ain't gonna work because, actually, P to the C plus 1 then is 12, but it should be 2 to the power of beta minus 1. That's not the case. This ain't divisible by 3, so we're not going anywhere with that, are we? So this case falls off, and then we look at this case, 2 to the B plus minus 1, 5 times 2 to, so if this one was 10, then this one would be 8. Okay, so P to the C plus 1 is equal to 10, and then P to the C minus 1 is equal to 8, and 2 to the B minus 1, this is 2 to the third, so B is equal to 4 in this case, and then P is equal to 3, C is equal to 2, and when P is 3, C is 2, that means that A is equal to 4, and we have our dear old solution. So we'd have another solution here, which would be P is equal to 3, Q is equal to 2, A is equal to 4, and B is equal to 4 as well. So, and then, let's double check to make sure we haven't made any algebraic error. That is to say 81, so minus 1 is 80, is equal to 5 times something. It's 5 times 16. We are good. It's a solution. So this is the case if A is even. Now, what if A is odd? What are we going to do? It's like, oh my God, I don't know how to deal with this. What will I ever do now? Well, let me then, okay, I don't know how to deal with this. I'm going to pause for 10 minutes. That's you right there. And I'm going to try to play around with something to give me an idea. What do I need to play around with? Small cases. Go ahead and do that if you haven't already, because, okay, let's try. So say the second case is going to be A is odd. Okay, A is now 1. But what happens if A is 3? What do we have? If A is equal to 3, what do we have? This might be worth a point, might not be worth anything. But it's good to give us just like a sense of what's happening. This would be P minus 1 times P squared plus P plus 1. Oh my God, what are we going to do with this? It's 5 times 2 to the B. Okay, so this is even. So this is going to have the 2 to the B. Now what about this? Well, this is, pause for 3 minutes and tell me what this is. It's an odd plus an odd plus an odd. So wait, this can't have a 2 at all. So this must be 2 to the beta and this must be 5. But that can't be, but this is at least 3, like this is at least 9 plus 3 plus 1, which is 13. So that's not going to work. What about A equals 5? What do we have then? We'd have P minus 1, and here we'd have P to the 4th plus P cubed plus P squared plus P plus 1. And it's an odd. It's an odd number of odds. Again, it has to be The 5 has to be here. We can't have anything to do with 2's. And then we can finish this in general. Now this might be like, whoa, how did this work out? What happened here? It's magic. I mean, the answer is, you try out a bunch of things. You see, like, what do I have? I have this. Sometimes it works, sometimes it doesn't. It doesn't work out. Okay, I'll try something else. But here, it ended up working. Yay, lucky us. But I mean, it's also, you want to try out different things and see which one lands. And here, this one landed. So, what's it called? Now that we have this part over here done, we'd write this in general. If A is equal to 2c plus 1, then we'd say we have that this side is p minus 1 times p to the 2c plus p to the 2c minus 1 plus all the way till p to the first plus p to the 0th, which is 1, is equal to 2 times 5 to 2 to the, 2 to the b times 5. And now this thing over here, we show it's odd because every single one of these is congruent to 1 modulo 2. So when you sum them up, they're congruent to 1 plus 1 plus 1. How many ones are we plussing? We're plussing 2c plus 1, which is congruent to 1 modulo 2. So this thing is odd, which means it can be only equal to 5. It can only be equal to 5 or a 1. But it's way bigger than that because p is at least 3 and c is at least a 1. And then we can find this here is greater than p squared plus p plus 1, which is greater than or equal to this, which is greater than or equal to 9 plus 3 plus 1, which is equal to 13, which is definitely greater than 5. And so this does not have a solution. And so we are done. That's the full problem. It's pretty linear in its thinking. There aren't many different ways you can solve it. Sure, you can use maybe lifting the exponent lemma in here and finish the problem with that as well. But it really, really doesn't make that much of a difference, right? It's very linear like this in your thinking. And I don't know, maybe you can say, okay, the power of q that's in p to the a minus 1, because q has to divide p minus 1. I mean, if q divides p minus 1, then we have def. I don't feel like doing that, right? It's not something that's interesting, not something you need really for JBMO. I don't know how I'd solve it with that. I just heard a couple of kids do it with that. It wasn't necessary. But it is some theory that ends up, helping out on this problem. Now, this finishes up our little problem. It's a cool little thing that we've done. And there's not, the lesson here is, write down everything you see. And even the small but insignificant, parity, come on, it's the third on the JBMO, come on, parity works. Even those small little ideas, try them out, and they can lead you to cases that finish the problem. And when you're stuck on a case, you can sometimes assume, this is even, finish the problem. It might give you partial points. And as always, thanks for problem solving.